องผมนะคุณอยากรู้ว่าเข้าไปได้เลยมีครบเกือบทุกวิชายกเว้นวิชามันกันสองสัปดาห์ไม่มี
ห้องนี้ไม่ให้เข้าอ่ะ
ไม่ได้เข้ากุลมัด
อ่ะนิ้วแข็ง
นิ้วแข็ง
ไม่เจอว่ะ
นิ้วแข็งได้ปะ
เจอออปติวเตอร์
อ้าวมันไม่ได้เสียบเหรอเสียบแล้ว
มันไม่ใช่สายชาร์จของมันเป็นสายชาร์จไอแพดสายชาร์จมันจะพังได้ยังไง
พิมพ์ชื่อไม่ครบไงเอาไปแต่แอนร้องเพลงไงพี่
เพื่อพูดตามคนเลยโอ้ย
ไอ้แอ๊ะอันนี้แบตกูจะเต็มลูกเนี่ย
เมื่อคืนเปิดปัดสายชาร์จเลยแบตเลยไม่เต็ม
มันหลวมได้ขนาดนั้นวะ
มันออกแบบมาใส่กับ iPad อย่างเดียวเอง
มันก็แพลตฟอร์มเดียวกันมั้ง
ทำไทป์ซีเหมือนกัน
รูเดียวกันแต่อันนึงหลวมแล้ว หลวมมาใช้บ่อย
โทรศัพท์ไม่อยู่มานานกับ iPad ไม่กี่ทีสับเครื่องไม่อยู่กูตั้งแต่หัวชอหนึ่งอ่ะ6 ปีได้ที่อ่ะ
ไอ้นี่เอเลยของเอเลยนะ
S
เอดับ
S3 S3 หรือ S4 ไม่รู้30หรือ40กูนั่น3-4ประมาณ
ของ
จำ
กู
ได้
5 ปีแม่งเครื่องมันอื่นแล้วไม่ไหวแล้ว จอแตกด้วยกล้องแตกอีกต่างหาก
ไอ้ที่นี่ก็คล้องแตก
แตกเพราะกูไปเรียนอดอนั่นแหละเฮียเขาบอกให้สไลด์ดีๆกูสไลด์วงเฉย
อาจารย์สอนนะเป็นไงบ้าง
นี่ครับไตผล
Okay, what did we learn last time? Last time we had studied how to develop a so-called PI controller. And this PI controller can connect into a parallel receive the same input, and the input of P and I here is pre-alert. So where is P, where is I? P is here. That is P controller. I is I controller. So P and I controller will have the same output and the same input. And this is called parallel connections of P and I. Okay, now for example, if I assume that we connect the circuit that I give the values of the resistor like this, 100k ohm, 100k ohm, 100k ohm. In P controller, I give gain is equal to 3, and I assume that I reduce 30k ohm and I is 10k ohm. In integrator, I will use the capacitor will have a values of 100 microfarads and 10 kilo ohm. The last one is called summing amplifier. The summing amplifier. The function of this summing amplifier is simply just to combine two atoms between P and I and send to output. So it is called summing amplifier. Simply just combine two effects. So output from the P controller I will call V out 1. And output from I controller I will call V out 2. And of course, because we don't need any gain at the summing amplifier, so I can use the same value of the resistor for all resistor in the circuit. Then I can define the gain is equal 1. So we just combine the effects of P controller and also I controller, you will get one output. And this is the output from the controller that you will send to the drive and control your actuator to move in the percent that you need from 0% to 100%. Input of this circuit is reset point and VPV. VPV come from the sensor in the automation process, and reset point is something that the operator will define. You can define it by using the adjustment of the voltage, or you can define it as the digital input is also depend on the structure that you have already built for your circuit. Today we will continue that how can understand that what should be the response of the output of the controller when we assume that we get the value from the sensor by time. Look like this graph. So this graph is something that you make a historical data. All the graph here is in historical data. Historical data means it will keep the data in each second for analysis. In the SCADA system, also you have to keep everything in the historical data. And in the market, it's also called, this is the logging data, or data logger. Data logger is the device that can keep historical data. Okay, we continue this. By this, with dead circuit on the right side, you have to evaluate the output signal from other amplifier. We out 1, we out 2, and we out from controller. Again, what is this? It is something that you measure from sensor by time. PV will connect to this input. What is this error amplifier? Error amplifier is V error in this position, output from the differential amplifier. Where is the Vout1? Vout1 is output from P controller. Where is Vout2? Vout2 is the output from integrator. Where is the Vout? Vout here is something that you measure at the output of controller. That is the combined effect between P and I. Okay, let's do one after the other. We start from the first one. The first graph is called V error. We can start from here. V error is equal to, what is the formula here? Because V error is the difference between V set point and VPV, so V error can be written as V set point minus VPV. Well, it is very easy, but you have to do it by chance. Okay, before we start to do anything, it is more clever to make a line between each connections. I will try to make a small line.
จบไปกว่าเองไม่ได้การรู้เรื่องได้มือมันก็ตีมันไป
Now I try to make the connections between time in each graph. First we start to do with the error. Error is equal to set point minus PV. So let's say the first interval here between 0 to the second interval time. So what is this? 5. We have a set point at 5 volt. It is the PV values. So what should be the answer here? So V error is equal to set point minus VPV. Set point is equal 5, VPV is equal 5. 5 minus 5 is equal to 0. So do we get something like 0 here? 0. Okay, the next step. You have 5 set point minus PV. Set point is equal to 5 volt and PV is equal to 4 here. So 5 minus 4 is equal to plus 1. So in this position you have plus 1. What is the next? The next is also 5. 5 minus 5 is equal to 0. The next step is 5 minus 6. It is equal to 6. 5 minus 6 is equal to minus 1. So you will have a minus 1 here. So minus 1 is 1 here. It's minus 1. Then the last step, you have 5 minus 5, then it is equal to 0. Then you have to continue to make the connection line. You will get something like this for the other. Do you understand? The next step we have to evaluate V out from P controller here. First, we have to understand the output equations of this circuit. So as we know that it is inverting amplifier. So we simply just write down the output equations. So V out 1 should be equal to gain multiplied with input. Input of this circuit is V and what is gain? Gain is RF divided by RIN. So you will have a KP whole multiplied with V. So what is KP? KP is gain is equal to RF divided by RIN, but it is in negative voltage because it is an inverting amplifier. Then you will get something like minus 30k ohm over 10k ohm, so you have 3 minus 3 multiplied with V. Try to evaluate V out. V1 is equal to minus 3 multiplied with V earlier. So you have to use minus 3 and times V earlier here. So V earlier in the first section here is 0. So you have a 0 multiplied with minus 3. Then output will equal to V. Output will equal to 0. And then the next interval here, we have the error of plus 1. So plus 1 times minus 3, then you will have a minus 3. So minus 3 is here. The next step is here. This interval you have 0. So you have the error of 0 volt times minus 3. You will get another 0 here. And these intervals, 1 second interval here, you have minus 1 of the error. So still this one, minus 1 times minus 3, you will have plus 3. Plus 3 is something here. Plus 3. The last section, you have this 0 volt. 0 volt times minus 3, you have 0 volt again. Then simply just write the connection line. You will get the graph look like this at the output of P controller. Do you understand? Who has questions? You can ask.
ซูมให้หน่อยได้ไหมครับ มองไม่ค่อยเห็น
Okay, may I repeat again? The first graph comes from the calculations of these equations. V error is the output of the differential amplifier, which is equal to V set point minus VPV. And V set point is defined here as 5 volt. VPV is according to the graph. And you have the first interval as 5 minus 5 is equal to 0. Then the next sections here, you will have a set point of 5 volt minus 4. Then you have plus 1. In these sections, you have 5 volt minus 5 volt, you get 0. So in this section, you can have 5 volt minus 6. Then you get minus 1. And the last section here, you have 5 minus 5, and then you have a 0 voltage. Then the second graph is the response of P controller at the output. So V output or output from P controller is equal to gain multiplied with V error at the input. Input of the inverting amplifier is V error, then we have to make a multiplications of gain. And gain in P controller is called KP. KP is equal to RF over RI in. You have 30 kilo ohm over 10 k ohm, then you have a gain of 3. Minus 3 multiplied with VL. Okay, that is the response of VR1. So the first section, you simply just take this VL of 0 to make multiplications to the minus 3, you have a 0. Then the second interval here, you will have a 1 times minus 3, you have a minus 3. So this interval, you have a 0 again, multiplied with minus 3, you have 0. The result of this interval is minus 1. Minus 1 times minus 3, then you have plus 3. And the last section here, you have a 0 times minus 3, you have 0. Until this step, if you have any questions, you can ask. Okay, if everyone can do it, then I will go to the next graph. The next graph is the response and the output of ion controller. Where is ion controller? Ion controller is here. Ion controller. That is VL2 that we want to know. But before we can do this, we have to know the equations of VL2 first. The equations of VL2 is like we learned last time, this also depends on the rate of change at the input. So I could divide dV out to by dt is equal to one factor, but this factor has to make a negative voltage because the input of the circuit is at the inverting pin, so we have a minus here. Minus Ki multiplied with V. So we do joule Ki values to joule the rate of change at the output of the controller. Okay, we continue. Now this equation is what is Ki? Like we learned last time, Ki is equal to 1 over Ri multiplied with Ci. And with multiplication to the input we learned. Then you will have minus 1 over Ri. Where is Ri? Ri in this case is 10 kilo ohm and Ci is 100 microfarads. So we have to make the multiplications between 10 kilo ohm times 100 microfarad and make up multiply with V alert. If you use the calculator to make calculations, you will get the first constant of 1. So 1 over 10 kilo ohm times 100 microfarad will equal to 1. then the last equation must be minus 1 multiplied between error. What is the unit? Mole per second. Why it is mole per second? Because now the equation is trying to determine this rate of change, the relationship between V out and out. So the unit will be mole per second. Last time I tell you that when you make the integrations, you always has a V plus V0 at the end of the equations. What is the meaning of V0 at the end of the equations? It is mean the voltage at the beginning. So I have to define the beginning voltage upon the capacitor that we use in the integrator circuit. And now I will define it as 0 volt. Let's see step. The next step is you have to make the calculations. In this calculation, you need the information of VL. So what should be VL2? VL2 is equal to minus VL. Minus VL. What is the VL here? The first interval is 0. So now you will get something like, in this interval you will get something like 0 volt per second. What is the meaning of 0 volt per second? 0 volt per second, it doesn't mean that you will get 0, but it means that it will have no change. So if the starting point is 1 volt, you will still have 1 volt. If the starting point is 0 volt, you will have 0 volt. That is the meaning of 0 volt per second. 0 volt per second is mean no change. No voltage change anymore. It also depends on the previous voltage. So now the previous voltage is 0. Then do we get something like 0? We continue to the next step. The next step is minus VL. The next step VL is equal to 1. So do we get VL2 is equal to minus 1. Minus 1 volt per second. In this interval, you will get something like minus 1 volt per second. What is the meaning of minus 1 volt per second? It means that in the next second, the voltage will reduce for 1 volt. The next second after the second before that you will get the voltage reading for 1 volt. So it means that now if the voltage is at 0 volt, in the next second it will go to minus 1. In the next second it will go to minus 2. The next second it will go to minus 3. And the next second will go to minus 4. That is the meaning. So minus 4 will be around here. Minus 4. Then I will try to make the connections. And this is the meaning of 1 volt per second. 1 volt per second. Okay, let's continue for the next interval. Next interval is again we have 0. No, again we have 0 here. So substitute is 0 in the equations, then you have a 0 volt per second. What is the meaning of 0 volt per second? It doesn't mean that 0 volt, but it will give no change anymore at the output. And the output from the previous second is at -4. So you will have a -4. You will continue to have a -4 for the whole section here. And this is the meaning of 0 volt per second. Kilowatt per second is mean that no change. So it also depends on the previous sections that what is the voltage state. And in this case, the voltage stay at 4 volt, then you will have no change anymore. You still maintain this -4 volt for the whole intervals. The last, not the last, before the last sections. Here, in these intervals, 1 second interval here, you will have a -1 error here. If you substitute this -1 error, then you will get at the end +1 volt per second. What is the meaning of +1 volt per second? It means that the next second will increase for 1 volt. So now the voltage stay at -4. Then in the next second you will have -3. -3 is around here. -3. It is called +1 per second. So if you have to work with integrator, you must exactly know what is the sign. Minus or plus. Plus is mean increase and minus is mean decrease. Okay, the last sections. You see here is VL is equal to 0. So now it's 0 volt per second again. 0 volt per second is mean it will have no change. So the previous second is at -3. Then you will still have -3. Is 0 volt per second. name here? Here is at the output of integrator. At the output of integrator, you interest in the change at the output by curve. So it can be calculated by these equations. dV output by dt is equal to minus Ki multiplied by V Euler. So you have to use the information of V Euler to analyze the response at the output of integrations. So what is Ki? Ki is equal to 1 over Ri and Ci. So you have to go to the circuit to see that what is the value of Ci and Ri. In this case, I define as 10 kilo ohm and 100 microfarads. So if you make the multiplications, you will have something like 1. Then you will have minus 1 over 1, then you have 1 here, multiplied with V Euler. You will have minus 1 Euler, and the unit in volt per second. So you simply just make the substitute of the V Euler in each time, in each second here, you will have this graph. If you get the result of 0 volt per second, it doesn't mean that you have to get the 0 at the output, but 0 volt per second means no change of the voltage anymore. So for example, if you have the starting point at 0 volt, you have to continue to 0 volt. But in this case, if we say that, for example, I have V0, if we have V0 is equal to 1 volt, you will have something like this. Do you understand? So also it depends on the previous voltage. If you calculate and you get 0 volt per second, 0 volt per second, it doesn't mean that you have 0 here, but it means that no change from the previous voltage. So if the starting voltage is not 0, you have to maintain the voltage. ถ้าจุดเริ่มต้นไม่ใช่0โวลต์0โวลต์เปอร์เซ็นต์แปลว่าไม่เปลี่ยนแปลง ไม่เปลี่ยนแปลงคือข้างหน้าเป็นยังไงต้องคงไว้เท่านั้น ถ้าเริ่มต้นด้วยเลข1แสดงว่าก็ต้อง1ต่อไปเหมือนอย่างตรงนี้0 โวลต์เปอร์เซ็นต์ข้างหน้าเป็นเลข-4ก็ต้อง-4ต่อไปดังนั้น0 โวลต์เปอร์เซ็นต์แปลว่าไม่มีอัตราการเปลี่ยนแปลงที่เอาพุทถ้าได้-1 โวลต์เปอร์เซ็นต์ลบกับบวกบอกทิศทางถ้าลบแปลว่าใน1เซกถัดไปจะลดลง1 โวลต์ถ้าตรงนี้เริ่มที่0เซกถัดไปก็จะลดลง1 โวลต์เป็น-1เซกถัดไปก็จะลดลงอีก1 โวลต์เป็น-2เซกถัดไปก็เป็น-3เซกถัดไปก็เป็น-4เข้าใจว่าOkay, this is the response curve at the output of integrator. Now let's see the combination effect between P and I. Now we will do the last section here. We try to evaluate what should be the output of the controller. In this case, so output from the controller is the output of the summing amplifier. If you can recall that the summing amplifier equations, it will have something like that. You have V out 1 plus V out 2 because the gain of the circuit is equal to 1. Then I can write the output equations like this. V out of controller is equal to minus. Why it is minus? Because you have input voltage, both input voltage of summing amplifier is at the inverting pin. So you will have output that out of it from the Vin. Then you will get the minus here. Then you have a minus V out 1. V out 1 plus V out 2. Only that is pretty easy for summing amplifier. Output equation of summing amplifier which have the gain of 1. Okay, now something might not be easy in this case. That means you must use the informations of V out 1 graph and the V out 2 graph. For the first step or the first section here, it will not have any problem. You will have only minus 0 plus 0, you will get 0. Okay, the difficulty will increase in the next step. The point is, if you see here, in the same time scale, you have two values of V out, not the same, not only one but two. So you have something like, I would say that this point is point A. This point is point A. Okay. This point A. This point is point B. Point A, point B. You see, the next, at this time scale, V out 1, you have two values. You have minus 3 and we have 0. At this time scale, you also have two values. The first value is 0 and suddenly it will change to minus 3, then you have two values. Then you have to calculate two values on the same graph scale. Okay, let's continue. At point A, you will have minus V out 1. Minus V out 1 is 0. Minus V out 1 is 0, but you have V out 2 only one values, that is 0 here. So we have 0 plus 0, that is equal to 0. That is point A. Then the next step, we calculate point B. Point B, you have minus 3 plus 0, minus 3 plus 0 on the same time scale. You have minus 3 plus 0. Then what should be the answer? Is plus 3. So at this point A, or point B, you will get plus 3 around this. Then we continue with point C and D here. Again, on this time scale, we are one, you have two values. You have -3 and you have 0. But at we are two, you have only one values, that is -4. So we continue with the next values. The next point is point C. Point C you have -3. We are one is equal -3 plus 1 minus 4. Then you will have here is -7 multiplied with minus, then you will get plus 7. Then plus 7 is something here. It is plus 7. The next step I will try to calculate deduct. What is deduct? Deduct is minus without 1 at deduct point is 0. You have a 0 and -4. 0 plus -4. Then you get 4 plus 4 on the same time scale. On the same time scale. Still be in this time scale. Plus 4 is here. Okay, next step, we see this time scale. And we have another 2 point, and this one, D, E, that is F. And again, this will be F, G, and H. Okay, let's see at point E. Point E you will have V1 is equal to 0, and at the same time scale you will have point E as -4. Then we can make a formula like this: minus V1 0 plus -4. You will have plus 4. This point we have plus 4 like this. This is E point. Then you will have F at the position F. You will have plus 3 and V2 is equal to -4. Then you will have the answer is it is -1 multiplied with -1 to get +1. Be careful that we are doing on the same time scale, this time scale. So your minus one must be on this time scale. Minus one look like this. You make the connections. And this is point A. The next time scale. The next time scale is H. E, F, G, no, not H, but G. Why G? Because your signal will go like this, then go up to F, then the next step must be G, and the last one is H. G, what is G? We have to do with our G position. Here is about 3 volt, and this point is minus 3. Then you will have minus plus T plus minus 3.
0
You will get 0. And this point is 0. T is here on this time scale.
ครับ G เป็นลบ3 G เป็น3ใช่ไหมครับ ตัวบนเป็น3 F ก็ต้องเป็น3ใช่ไหมครับ ตรงจุด F นะครับ มันเป็น3เท่ากับ G ใช่ไหมครับ ใช่ไหมครับ
ก็เป็น3กับ
F. F is minus 3. 3 plus minus 4. So you have a subtraction, you have
จุด
minus
F มันยังอยู่
1,
นี่
then
ไง
you have
เอา
plus 1.
มันยังอยู่ลบ4อยู่
ไม่
So
ทัน
you have a different values.
งั้นจุด F มันก็ต้องเป็น
ลบ1
3เหรอ
It's 1G. Okay, the last one. The last one must be H and H position. At H position, you will have 0 and minus 3. So minus 0 plus minus 3. Then you will get plus 3. Plus 3. Be careful that you must mark on the same scale, on this time scale. Then you will have 3 on this time scale. Then this plus 3. And then the last one, you have only one value. You have minus 3 out 1. 3 out 1 is 0, and 3 out 2 in this interval is minus 3. So 0 plus minus 3, you will have the end is equal to plus 3. Like this, plus 3. The difficult and must makes you confused is when you have something like real estate here. or you have a step on the same time scale, you must calculate 2 points on the same time scale.
ชาร์จได้ไหมอ่ะ
Okay. That all for the controller. Do you have any questions? If you don't have any question, we will continue with derivative controller. I make a break for 10 minutes, and then we go back to learn about the derivative and PID controller.
ไม่หาในทางไหนเลยไอ้ที่นี่กูชนชั้นสูงได้
จะได้เป็นคนงานตอนแบบ